Okay, here we go. Today we're looking at getting ready for 6th grade. Lesson 15, polygons on a coordinate grid. And what is a polygon?
It's a 3 or more sided figure that closed figure made up of one side.
3 or more line segments. Good job. So closed figure made up of 3 or more line segments. So give me an example of one. A hexagon.
Square.
Well, that's not. Let's try. What is another classification for a square by its side? A quadrilateral. Hexagon. Getting harder, isn't it?
Octagon.
An octagon. A decagon. Nonagon. Okay, here we go. How can you plot polygons on a coordinate grid? What do we already know about putting points on a coordinate grid? What do we have to know what the points are?
We have to have like a y-axis.
We have to, on our coordinate grid, we have a y and x axis, and we need to know the ordered pairs that we're putting up there, right? And if you look at that little box, it gives you those. Okay? So you have learned to plot points on a coordinate grid. You can use that skill to plot polygons. Camille is designing an indoor greenhouse on a coordinate grid. The floor of the greenhouse is a polygon. The vertices of the polygon can be graphed using the coordinates shown in the table. Plot and describe the floor of the greenhouse. So, why would you want to put it on a coordinate grid?
So you can tell where it's going to be. And what the shape is.
The shape? How about, could you say, well, each one of my squares represents
however many inches
inches or feet or whatever, so you could get the size you wanted. Okay? In our little gray box it says, what do x and y represent?
Like the up, down, side, vertical line of the table.
Okay.
How to mark these.
Right, how to mark our coordinates also. So each, I'm going to write this over to the side bigger. Each, and we're going to put x, y, what do we call those?
Axis.
Pair. We call that an ordered pair. So each x and y pair represent the x dash and y dash, sorry, that's the dash coordinates of a point. Okay. Okay, so if you need to, you should stop your recording. Write ordered pairs. Use each row of the table to write the ordered pair. So if you look at this table here, you can see that it has a column for x and a column for y. And so if we put an x and a y, our first ordered pair is 10, 1. What's our second ordered pair? 2. We're going across like this. And the third ordered pair?
2, 1.
And the next one?
16.
And
6.
now it says to graph those points. So we're going to go across 10 and up 1. We're going to go across 2 and up 6. We're going to go across 2 and up 1. We're going to go over 6 and up to 10. And we're going to go over to 10 and up to 6.
wants to connect our lines.
So the floor, oh yes, it says in step 3, connect the points. So I'm just going to start down here, and you start where you want. Remember, we're making a polygon, so we're not going to probably crisscross across anything. So the floor of the greenhouse is what shape is that? A pentagon. What if the greenhouse floor had only 4 of the 5 vertices given in the table and did not include 6, 10? So what if it did not include this one? What would the shape of the floor be? Well, I've heard square, rectangle. If we go from 2 to 10, that's 8 points, right? And if we go from 2 to 6, that would be 4. So it would look, sorry, I'm trying to change the color of my pencil. It would look like this. So it would be a rectangle. A parallelogram on a coordinate grid has the vertices of 3, 4, 6, and 1, and 8 and 4. What are the coordinates of the 4th vertex? Explain how you know. Okay, I am going to erase our little pentagon we did. Do our numbers go far enough? We can make it work. So that we can draw these on here and talk about what our possibilities are. So the one they give us are 3, 4, what else? 6, 1, and 8, 4. And what are we supposed to be making? Just says a parallelogram on a coordinate grid has vertices at. So here we have this parallelogram. Where else could we put another ordered pair to make that be a parallelogram?
2 and 1.
Well, let's try 2, 1. If I do 2, 1, I'm going to come down here and here. Does that work?
Yeah.
We're 2 over, and we're, oh, I don't know that, I think we don't want to do 2, 1. It's not straight, but this one crosses 2 lines, and this one only crossed 1. So I think we need to try, instead of 2, 1, well, we need to come back this way 2 spaces, so we need to try 1, 1. And then we have 2 sets of parallel lines. So we can put an ordered pair of 1, 1. Remember that we put a parenthesis, we put our first, our x coordinate, our comma, then our y coordinate, and we close our parentheses. Okay? So let's talk about getting an eraser. Let's talk about where else we could put one. Where else could we put a point?
You put it on like 10, 1.
10, 1. So right here he says. Okay. If we're doing that, we're crossing 2 lines here. How many lines are we crossing here? 1, 2. Yeah, we're going to 2. So can we do 10, 1? What would we need to do differently? 9, 1. 11, 1. So we need to add a little extra line out here on our grid.
We can do 7, 8, too.
Okay, let's finish this one. So we said we could do 11, 1, which would be right here. And if we, I must not have that one where it needs to be. What was our first coordinate? Something 8?
3, 4, 6, 1, 8.
Oh, I have that one too. Okay. Eight, 4. Okay. So then there we would have a parallelogram. So there's another ordered pair. 11, 1. And I heard somebody else say something that I thought was something 7. Was that true?
Yeah,
7, 8. We have 6, 7 right here, so, right? Didn't we have 6, 1 as a given?
So 7, 8 we put it.
Okay. Oh, so you're saying 7, 8. Well, gotcha. I was looking at it wrong. 7, 8. If I am only crossing one line here, but I'm crossing quite a few.
Yeah.
Okay, so let's reposition that. We can do, instead of 7, let's try 5. Instead of 7 first, let's try 5, 7. So then we would have a parallelogram that looked like this.
Yeah, and the square isn't parallel.
Yeah. That's 2 sets of parallel sides, right? So 5, 7. Okay, and we're supposed to explain. So it says, I plotted the 3 points on a coordinate grid and joined them to make 3 sides of a parallelogram. Then I used the shape to find the 4th vertex. So that's what we did. I'm going to go ahead and stop this and get that in there. So here it is, typed out for you. Please stop your recording and jot that down. Okay, now we flipped over to page P280, and it says plot the polygons with the given vertices on a coordinate grid and identify the polygons. So 2 things here. Don't forget to do both. So we're going to go over here. We're going to plot a point at 9, 6. We're going to plot a point at 1, 7. And we're going to plot a point at 3, 1. Then we're going to take our pencil and we're going to connect these. And what shape does this make? A triangle. And we're going to go on to number 2. And we're going to plot a point at 1, 6, 8, 4. Don't forget to go across on your x-axis first. Then we're going to plot a point at 1, 4, and another one at 8, 6. And when we connect those lines, we're going to have a If you look at the problem solve, it says a football field is a rectangle measuring 300 feet by 160 feet. Each unit on the coordinate grid represents 1 foot. 0, 0, and 0, 160 are 2 of the coordinates on the football field drawn on a grid. What are the coordinates of the other 2 vertices? So if we had, I'm just going to do it on this, well, if we had 0, 0, what else could we draw? What other points could we put? It's going to be 300 feet. So we need to go 0, 300, 0. And we would need to go what else?
160.
So we're going to put 300, 160. So they'll be parallel to these points.